Hello folks, we are once again back with the miscellaneous exercise. We were at this question number 6 we've completed. So let's go to the question number 7, and the question number 7 says that you're given the function f of x as x cube plus 1 over x cube, and they tell us that you have to find the interval where it is increasing and decreasing, and we very well know how to do it. What we do is we get across with the first derivative, and then from there we get the critical point, there we break the interval, and so on. What we did, maybe in some one or two problems earlier we did do it. So let's go across doing it. Let's go for the critical point. So in order to get this derivative, the easiest way is you could call this as x raised to minus 3. So in order to get the first derivative, x cube is 3x square, and this is x raised to minus 3. So by formula, minus 3x raised to minus 4, which is 3 times x squared minus 3 over x raised to 4. Let's take the 3 common. X square minus 1 over x raised to 4. Let's get it simplified. Times x raised to 4 times x raised to 4. So 3 times x raised to 6 minus 1 over x raised to 4. We have learned this earlier, that x raised to 6 minus 1 can be like split as x minus 1, x cube minus 1, x cube plus 1 over x raised to 4, which can be further split as x minus 1. In the 9th standard, we have learned a cube minus b cube is a minus b times a squared plus ab plus b squared. So let's use that. X minus 1 times x squared plus 1, x squared plus x plus 1. And a cube plus b cube splits as a plus b times a squared minus ab plus b squared. So x plus 1 times x squared minus x plus 1. So this is how it's split, and that helps us to get the critical point. So let's go on to get the critical point. So let f dash x be equal to 0. So you are getting maybe 3 times x minus 1 into x plus 1 times x squared plus x plus 1 times x squared minus x plus 1 over x raised to 4 equal to 0. Let the x raised to 4 go there, let the 3 also go there. When it goes on the other side, because of the 0, all that will get eliminated, and you're left with x minus 1 times x plus 1 times x squared plus x plus 1 times x squared minus x plus 1 times 0. Whenever a product is 0, each term is 0. So therefore you will have, therefore x minus 1 is 0, x plus 1 is 0, x squared plus x plus 1 is 0, or this is a possibility, or you could also have x squared minus x plus 1 0. Any of these possibilities would be true. So if x minus 1 is 0, it means x is 1. So that is one possibility. Other possibility is x is minus 1. Now for this and this, you will not get the value of xy, because this is a quadratic. So you could apply the formula minus b plus or minus root of 4b squared minus 4ac, but you'll get negative roots and you'll not get real values. So actually I think it's worth trying. Let me search my duster. Yeah, so let's try to get the values over there. You will be able to get, here also you have x squared minus x plus 1 equal to 0. If you are trying to get the root minus b, that's minus 1, plus or minus root of b squared, that is 1, minus 4ac, that's 4 over 2. So this is a negative root. Because this is a negative root, you will not get x does not exist. Okay. Same way here. Minus b is 1 plus or minus root of b squared, which is 1, minus 4ac, 4ac over 2a. Again, this also negative root, so x value does not exist. Okay, so the x value is not existing. The existing values are 1 and minus 1. So that will help us to distribute the interval. Suppose say if you have your real number line like this, where you have minus 1 and 1 here, then you have all these intervals split up. So let's go right away and find out how these values are. Like how we discussed in the previous question, we can have, in order to analyze this, we can have these 3 columns. First column, we can call it as interval. Second column, we can call it as sine of f dash, and then we can tell the nature of the function, nature of fx. So first interval obviously is from minus infinity to minus 1. Can take any value in that, maybe minus 2 or minus 10 or something like that. So we look at f dash. Yeah, f dash is this. This should be good. You can take any value. You can take this. So f dash at maybe minus 10 can we take, or minus 2? Minus 2. So minus 2 raised to 6 is definitely, raised to even power is always positive. So it's going to be a positive power. This is also going to be a positive power. Minus 2 raised to 6 is as good as 2 raised to 6. And 2 raised to 6 is 64. So it's going to be positive. It's going to be positive. So what will happen there? It will be an increasing function. Let's go from minus 1 to 1. That's going to be our next interval. So in this interval, you take any value. For example, let's take 0. So in this case, if you try to put 0, 0 minus 1 over 0. Oh, that's not defined. Let's not go for such debatable values. Between minus 1 and 1. Take half or something. What else? There's no way out. Or you can take maybe 0.1. Take 0.1, or you can take half, 1/4, 3/4, minus half, all those values you can take. Suppose if you take f dash as 0.1, then 0.1 raised to 6 is going to be 0.00005 zeros and 1 minus 1. So obviously it's going to be a negative value, and then here also 0.1000. It is going to be a negative value. Yeah, you can actually look at the working like this. F at 0.1, f dash is going to be 3 times 0 raised to 6. No? So 1, 2, 3, 4, 5 minus 1 over raised to 4. So 0.1, 2, 3. And see, if you have 1 minus this is obviously going to be a negative value, minus 0.0009 or something like that. So that's going to be a negative value, and that way this will be decreasing. Same way, if we want to extend this to the next interval, that is 1 infinity. 1 infinity is our next interval. Okay, 1 infinity, f dash, you can take 2 or 10 or something like that. Yeah, same way, 2, okay, 2 if you want you can take. So if it is 2, again same technique, that it is 3 times 2 raised to 6 minus 1 over 2 raised to 4. All this is positive. 2 raised to 6 is 64. 64 minus 1 is 63. So everything is going to be positive. So here it is increasing. That's it. That's what they ask us to show. They're telling, come on, you take this function, break it up and show where all it is increasing and where all it is decreasing. So that's exactly what we have done. We have shown where it is increasing, where it is decreasing. That's all for this problem. In the next problem, let's meet in the next video. Bye-bye.